What type of bond exists in the salt calcium chloride? Calcium is a metal and chlorine is a nonmetal, so you're going to land up with an ionic bond, and therefore C is your correct answer. What type of force holds the particles in calcium chloride together? An ionic bond is held together either by ionic forces or electrostatic forces, or, because electrostatic just means that it is an attraction between positive and negative, or another word is Coulombic forces. All of those mean the same thing, an attraction between positive and negative. So it's C again. What is the correct name for the forces between the atoms of hydrogen chloride? Hydrogen, chlorine. Chlorine has a higher electronegativity than hydrogen, so the dipole exists in that direction, with the chlorine being slightly negative and the hydrogen being slightly positive, and therefore you land up with a polar covalent bond between the atoms of the molecule. What is the correct name for the forces between the atoms of a fluorine molecule? Fluorine shares the electrons in the middle exactly evenly. And when you have an exact sharing, remember it's between the atoms, it's not between molecules, you land up with a non-polar covalent bond. What is the correct name for the forces between the molecules of carbon tetrachloride or tetrachloromethane? It's the same word. It's C, Cl, Cl, Cl. So that is your polar bond, your non-polar molecule. And non-polar molecules are held together. What holds the molecules together is London forces. What is the correct name for the forces between the ions of a potassium fluoride crystal? Well, potassium is a metal and fluorine is a nonmetal, and they hold together by ionic bonds, ionic forces, or, if you prefer, Coulombic forces or electrostatic forces. So what's given to me as an answer here? An ionic force. What is the correct name for the forces between the atoms of a copper rod? Copper is a metal. So metals are held together by metallic bonding. So that you could have also said Coulombic or electrostatic, because it is a force between positive kernels and a sea of delocalized negative electrons. What is the correct name for the forces between the molecules of water? So here's one H2O, it's a dipole. Here's another H2O, it's a dipole. What holds one H2O to the next H2O is a dipole-dipole. Bee-bar, bee-bar. No, it's not, because it's water. So water, ammonia, and hydrogen fluoride are held together by hydrogen bond forces. What is the bond in magnesium? Metal. Fluoride, non-metal, and therefore we are in a ionic bond once again. What is the bond inside a molecule of iodine? Iodine is held together by a non-polar, because it's two identical atoms, non-polar covalent bond. The atoms hold together by a non-polar covalent bond. What is the intermolecular force? How does one iodine molecule hold onto the next iodine molecule? Well, these are both non-polar covalent, so you land up with a force between the two of them of a London force. So the bond is a non-polar covalent. The intermolecular force is a London force. What type of bond is found in the ammonia molecule? The bond inside the ammonia molecule is a, sorry, that's a circle. The bond inside the molecule is a polar covalent bond. So that over there is a polar covalent bond. What holds one ammonia to the next ammonia? I need to say one ammonia, NH3, is a polar covalent. Another one, NH3, polar covalent. So that's dipole, dipole. They hold together by bee-bar, bee-bar. It's ammonia. It's ammonia, water, and hydrogen fluoride. It's not dipole, dipole. It's a special dipole, dipole. and that is your hydrogen bond force. What type of bond holds ion together? Ion is Fe, and Fe is a metal, so metallic bonding holds that lattice together. And what holds the molecules of ice together? It is exactly this story. Water being held onto water. Ice is just solid water. And what holds those molecules together? And that is, again, a hydrogen bond force. What holds the particles of sodium chloride together? It's Na, metal, chloride, non-metal, and therefore it is an ionic bond. What holds the molecules of chlorine together? The particles of chlorine together. I would say that one chlorine, Cl2, holds hands with another chlorine. It doesn't say the atoms. It says the particles. Maybe molecules would be better there. But what holds those two together? Nonpolar covalent, held together by London forces. The best answer we've got there is van der Waals. What holds the molecules of copper together? Those are particles of copper together. And the particles of copper are held together by, it's a metal only, so it's a metallic bond. What is the difference between a hydrogen bond and a covalent bond? Hydrogen bonds are an intermolecular force. A covalent bond is a strong sharing of electrons. Okay? So a hydrogen bond, it's an intermolecular force, is always weaker than the strong sharing of electrons. Hydrogen bond does not occur between identical atoms. It does not only occur in the gas, in fact it occurs in solid and liquid, and it is exerted in a very specific direction from positive to negative. So that's not true. A non-polar covalent bond is formed between atoms with different electronegativities. Definitely not. We want the same electronegativity. Atoms of two different elements in the second period. Let's try. Magnesium's in the second period and chlorine's in the second period. I lied. Fluorine's in the second period and lithium is in the second period of the periodic table. And therefore, you land up with a metallic bond there. That is definitely not a nonpolar covalent. What about the ions in an ionic crystal? Plus, minus, definitely not covalent. What about the atoms of elements in group 7? Chlorine when it bonds to chlorine. Fluorine when it bonds to fluorine. Iodine when it bonds to iodine. Bromine when it bonds to bromine. Those look like nonpolar covalent bonds. That looks like a good answer. What is the shape of the BF3 molecule? It's one of your classics. The B has got 3 electrons that can participate in bonding, and you land up with a trigonal planar molecule. It has a steric number of 3, and all 3 are occupied by an atom. In which of the following molecules is the covalent bonds most polar? Well, that's nonpolar and that's nonpolar, so let's ignore them. Hydrogen chloride. Chlorine's got a high electronegativity when I compare it to iodine. So chlorine and hydrogen will have a bigger difference of electronegativity, and therefore hydrogen chloride is the most polar. Which type of bond keeps the atoms in a molecule of hydrogen gas? So I've got hydrogen and hydrogen. What holds those two hydrogens together? And that is a nonpolar covalent bond. The reason why water has a polar covalent bond is oxygen has a higher electronegativity than hydrogen. That would cause something to be polar. Sure. There are 3 atoms in the molecule. That doesn't cause it to be polar. For example, carbon dioxide is nonpolar and it has 3 atoms. So that's not the answer. Hydrogen is smaller than oxygen. So what? It doesn't cause polarity. And water boils at 100 degrees and freezes at 0 degrees. It's a true fact, but it doesn't cause polarity. So A is my correct answer. Which one of the following best describes the forces of attraction between molecules in solid rhombic sulfur? So if I've got sulfur, 8 sulfurs all stuck together, sulfur, 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 that will form a nonpolar molecule. They've all got the same electronegativity. What holds a whole bunch of nonpolar molecules together is van der Waals forces. Why does sodium chloride dissolve in water? Sodium chloride is ionic. Water is polar covalent. So, the ions can attract the dipoles in water. That looks like a good answer. Water and sodium chloride are both, no, they're not both ionic. One is covalent. Ion dipoles are strong. So what? That's got nothing to do with whether it can or can't dissolve. And actually, ion dipole forces aren't very strong, by the way. And all salts dissolve in water. That is simply not a truth. So the only correct answer is A. Which of the following interparticle forces do not exist between certain particles in a sodium chloride solution? So in my sodium chloride solution, we have the following. I'm going to pop my sodium and my chlorine into a container of water. So my hydrogens, which are slightly positive, will face onto the chlorine, which is slightly negative. My oxygen, which is slightly negative, will face onto the sodium, which is slightly positive. The oxygen and the sodium are attracted. The chlorine and the hydrogen are attracted by ion dipole forces. The water attracts the other water by hydrogen bond forces. The sodium attracts the chlorine by ionic bonds. So the only one there that is not true is the London forces. We've got these 5 things: sodium, diamond, methane, neon, sodium chloride, and water. Which of the following substances is a solid which melts far below room temperature, so it's got weak intermolecular forces and has mainly got London forces? I'm first going to think about what these 5 things have in them. Sodium chloride is Na plus and Cl minus. It's an ionic bond. Water has got a polar covalent molecule with H bond forces between them. Methane is your CHHHH, so it's your polar bond and your nonpolar molecule. As a nonpolar molecule, it has got London forces between it. A diamond is covalently bonded carbon, 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 and it is an atomic lattice. And your sodium is on the far left-hand side of the periodic table, so it is a metal or a metallic lattice, and that is ionic. Let's see what they ask us. The first one is which one is held together by London forces? Methane. Then it says to you which one has got a high electrical conductivity. The only high electrical conductivities are going to be metals, so it must be sodium. Then it says to you which ones have got a high melting point and the atoms are all covalently bonded together. Every single one covalently bonded to the other one must be diamond. Then they say which one is hydrogen bonding pronounced. Hydrogen bonding is in water, ammonia, and hydrogen fluoride. So the answer is going to be water. And then finally, they ask us which one does not conduct electricity normally, but is a good conductor if I melt it. Now we know that ionics don't conduct, but they do conduct in the liquid phase. So sodium chloride is your correct answer. What holds the atoms of a diamond together? Here's my atomic lattice. It is held together by covalent bonds. What type of a lattice have you got? An atomic lattice. What type of force holds hydrogen chloride molecules together in the lattice? So you've got hydrogen, chloride. Next, hydrogen, chloride. What holds those together? This is a dipole. This is a dipole. So what holds them together? A dipole-dipole intermolecular force. What type of lattice is formed in hydrogen chloride? Those are molecules that are all attracted to one another. So this is going to be a molecular lattice. Iodine and chlorine are both found in the same group in the periodic table. At room temperature, chlorine is a gas, whilst iodine is found in the solid form. Why is this so? Now watch carefully. Here's my chlorine. It's little. It's got hardly any electrons. It's got to form a dipole. One side will just for an instant have to become slightly positive, the other side slightly negative. Very few electrons to do that. So it has got small instantaneous dipoles because of low electron wobble. When I look at something big like iodine, I will have big slightly negative, big slightly positive. So I will have big instantaneous dipoles due to electron wobble. So if I read through the answer that's given here, iodine has a stronger intermolecular force than chlorine. So it's more likely to be a solid. Chlorine is much smaller than iodine. The additional electrons of an iodine molecule allow for greater electron wobble, and hence a stronger instantaneous dipole is formed. This means that there will be a stronger interforce. It's a stronger electrostatic force in the London forces, and therefore a higher boiling point.